Real quick note about the Southern Rockies Fire Science Network. We're a national network of fire science exchanges that is funded by the Joint Fire Science Program. We're funded by congressional appropriations, and the funds are managed through the BLM, the Bureau of Land Management, in the National Interagency Fire Center in Boise, Idaho. And the purple areas are what we're covering today. I'm the director of the purple areas, all the way from southern Wyoming to where we stand now in eastern Utah, to the Front Range of Colorado. And the purple thumbnail that you're looking at in the plains is the Black Hills. And so we help to support and facilitate and create exchanges about relying on science between researchers and managers and communities, so that we're moving forward with solution-based management decision, science-based management decisions for wildfire management solutions. And we'll go forward. So part of our funds help to support the Utah State University Forestry Extension Program, including their biomass program and the Utah State University Forestry Extension webinar series. So please, if you're interested in more events like this and keeping up with anything wildfire related, invasive species, any wildfire, regional wildfire topics, take a look at our website, southernrockiesfirescience.org. Continuing education credits will be offered for this webinar through a variety: a Society for Range Management, Society of American Foresters, Society for Ecological Restoration, and the North American Invasive Species Management Association. So what we need you to do is, and we'll post this link several times, is to go to this link and fill out the form and let us know which organization you're claiming credits for, and we'll send them the roster. People who are also here in attendance, I also have Society of Range Management forms available as well. And let's see. That's an ending slide. So before we back out, just another note about our field trip tomorrow. We'll be touring, on a field tour, we'll be touring treatment sites in the Cache Valley. And those of you who are attending in person, if you have not signed up for the field trip already, please join us tomorrow. We can check in with you after the webinar is over about where to meet, what time. But we have enough lunches and we have enough room. So if you haven't signed up, you're still welcome to come. The topic I wanted to talk about real quick, cheatgrass, Medusahead, and Ventenata grasses. Most of us here online and in person have a general idea of the serious implications of the spread of these grasses are having to the Western United States. And it used, from my understanding, we were under the impression that Medusahead and Ventenata would not be crossing the Continental Divide in Wyoming, and now it's been found in northeastern Wyoming, and there's very active groups there that have been forming to manage it. So cheatgrass, Tom Monaco will later be talking about the implications and giving us a basis for why we're having this webinar again and what we're doing about it. Every year, every several months, there's new treatments and new options that are coming available. And it's of crucial importance to management of our range and habitats in the West. So I'd like to step out of this presentation and minimize, and we'll get ready for our surprise speaker who is standing by and being very patient. Oh no, wait. I'd like to introduce Dr. Harry Quick, who is the Western Region Stewardship and Development Manager for Bayer Corporation. And I'd like him to step up a little bit. We've worked together for a couple of years now for these webinar symposia. And I'd like Harry to just take a couple minutes and talk about how these research projects in between a variety of Western universities and Bayer Corporation have gotten started, and how we work together with Southern Rockies Fire Science Network, and how Bayer plays a part in all this. And then we'll introduce our surprise speaker. Thanks. See the presentation. So go down here. Yeah, and yours should be one of these. On this one, that one. And you're this one?
Yeah.
Okay, and then you need to be in presentation mode.
Okay.
And I think you got it.
I'm good. Yeah, thanks, Gloria.
Success.
Appreciate the introduction. So yeah, so Gloria asked me to just give a brief overview of why and how Bayer is involved in annual grass restoration across the West. This is the 2010 sagebrush steppe fire in Jefferson, 100,000 acres. There were 2 centimeters of soil lost from this area, so reducing the organic rich soil microsites and leaving hard crusts. This photo and research is by Matt Jamino with USGS. Okay. Gonna help us forward. Okay.
Where do you need it?
Slide down.
Seems like these are only working when we restart them.
Yeah.
This is the correct mode.
All right, so I've got the next slide going here. Sorry about that. So this is, in addition to losing the topsoil, we also have the air pollution to consider. This is dust from a long draw fire hitting Boise, Idaho on the 5th of August, 2012. That fire was about over 100 miles southwest of Boise. So how do we get there? How do we get these fires? Landscapes throughout the West are under threat of wildfire because of the invasion of the annual grass. After these fires, the perennial shrubs and the vegetation really battles to recover, the grasses and the shrubs, because of the increased fire frequency. The sites gradually transition into near monocultures of invasive annual grass. This is cheatgrass in Nevada. This is Bromus secalinus invasion after the rim fire in the California Sierras. In the desert Southwest, we have red brome and cheatgrass invading. These sites are not adapted to wildfire. Very important species are under threat now. That's a Joshua tree in the background, not adapted to wildfire. Same thing with desert tortoise, an endangered species. It has real problems with the red brome invasion in the desert Southwest. So in came Esplanade 200 SC for invasive annual grass control. We started a project at Colorado State University. Colorado State documented long-term control of cheatgrass and release of perennials. So since the fall of 2015, we've been working with land-grant universities and agencies across the West. We now have over 100 replicated field trials documenting the efficacy of Esplanade for annual grass control in the West. So what can we do with this transformative product? This is Medusahead release in Utah, releasing western wheatgrass that you can see there. This is Ventenata releasing smooth brome, this site in northern Idaho. And this is cheatgrass release in Colorado, releasing a range of desirable forbs and perennial grass species. We can use this for restoration of conifer production areas and for fire break creation and maintenance, for restoration of natural areas and wildlife habitat. This is Boulder County open space in Colorado, treated on the right-hand side. We've documented pollinator habitat restoration after these treatments. And we've also documented improvements in wildlife habitat. This product's also being used already for restoration of natural parks and also, most importantly, protection of people. This is Zion National Park, very concerned about cheatgrass-fueled wildfires moving into the main canyon, where at any one time there are thousands of people up there. And our next speaker, Gloria will introduce our next speaker, who's going to speak directly to what can happen if wildfires impact communities.
Okay, you ready? Okay, well, our technical specialist steps up and helps us switch the screens.
Just so everybody knows, that is not my background.
But he's doing a great job, better than me.
You ever seen
So-
a wildlife biologist try to run a computer?
Oh, that's why we're having a great time. So, oh gosh, now I'm having feedback on my computer. So, excuse me a minute. Okay, folks, let's hope that's the last of our technical problems. A couple months ago, Dr. Quick and I were at the After the Flames conference in Colorado, in Denver, Colorado, and there was a special presentation given by a man named Woody Faircloth at our reception in the evening after the end of the presentations for the day. And Woody has done what a lot of us wish or say that we would do and never seem to get around to, which is take his personal time, personal funds, personal motivation, and resources to go help the people who've been devastated by the campfire in Colorado. And if there's anything that can bring us to the reasons why we should be, this is not moving, reasons why we should be working on these invasives and cheatgrass and managing these species, it's this kind of work. So we'd like to introduce Woody Faircloth and have him talk about his project, RVs for Campfire Families. And Woody, there you go.
Hi. Can you hear me okay?
Yeah.
We can hear you. Can you share your screen, Woody?
I'm going to do that right now.
All right.
It's really quiet. I don't know if we can get his.
Okay. Let me present.
Woody, can you talk a little louder or closer to your microphone?
Yes, how's that?
Perfect. Thank you.
Okay.
Okay.
No
Woody
problem.
has the floor.
Well, when I heard there was a surprise speaker, there's no one more surprised than me to find out that I'm that person. I know nothing about what you guys are talking about, and I think that's probably why you're having a seminar to do that. Can you hear me okay?
We can hear you, but we're having trouble getting your screen up on the share screen.
So let's wait just 1 second. So
Okay.
everybody that's joining us on the webinar can see Woody right now. It's just everybody that decided to actually physically show up. So we're gonna try to change that and get Woody's video up on the
Right.
screen
So
here.
everybody
but
on the webinar online can see this.
I believe so, yes.
Awesome. All right, I'm gonna go check my questions and see.
Well, I can talk through this part while you're doing that if you'd like.
Go ahead and talk us through, Woody.
Well, my name's James Woody Faircloth, and I'm a national account manager with Comcast. I can't fix all your Comcast problems, but I've been a telecom executive for 30 years. I graduated from Wake Forest University in 1990. I married my college sweetheart. I got an MBA nights and weekends. I have 4 kids. My 2 oldest sons graduated from West Point and are serving in the U.S. Army. I have a 17-year-old daughter who just committed to play lacrosse at Cornell when she graduates high school next year. And I have a 6-year-old daughter named Luna who's in this picture. And she still thinks I'm cool enough to hang out with, and is a bit of a sidekick. And I'm currently retired from marriage. That didn't work out for me after many years. So this past Thanksgiving, I had planned to take the week off with Luna. And
Oops.
taking a look at her for
Still there, Woody?
Yeah, I'm here. Can you hear me?
I can hear you, yes.
Just so you know, I have a webinar up here and I can see Woody's presentation.
Oh, you can?
Yeah.
Oh, I'm just trying to, I know everybody else can see it. I want
Cool.
everybody here to see it as well.
Oh, gotcha. Yeah, so we were trying to figure out what we were going to do for Thanksgiving and had no idea what I was going to do with this little girl. And this is where I get to the next slide. You want me to wait or you want me to proceed?
Oh, go ahead. Sorry, you're good, Woody.
Okay. So like probably a lot of us, we were watching kind of in horror these videos that were coming out of what was happening Paradise, California on social media and in the news, and I thought to myself, like I think we all often do, you know, that's so awful. Those poor people. You know, I wish there was something we could do. And then I saw news reports that really stopped me in my tracks. I had heard that dozens of first responders had lost their homes in the fire, along with 50,000 people, like newly homeless Americans, just a couple of weeks before Thanksgiving, and now most of them were sleeping in their cars in tents, and it was just incomprehensible to me. Let's see, how do I go to the next slide while I'm playing a video? Shoot. So in total, the campfire destroyed 14,000 homes and some 5,000 businesses and other structures. It was just completely incomprehensible. I couldn't even get my arms around that. So we decided we had to do something when we saw news reports like this. So yeah, I mean, this is shoot, sorry. This is the week of Thanksgiving, and I just couldn't sit around and do what we usually do on Thanksgiving, argue with loved ones and, you know, eat ourselves into nap time and watch football and do stuff like that. So we had decided we had to do something. I just didn't know what it was. And so I went on to, I had to Google the nearest city to Paradise, California. I didn't even know what it was, even though I lived in the Bay Area for a few years with Comcast about 10 years ago. And I saw the Chico, California Craigslist site, and I just went into the community section. I don't know what kind of steered me here. But I saw people just crying out for the need for housing, which was pretty obvious based on some of those news reports that I saw. And I saw one post from a guy who said he was able to start his RV up on the side of his house and escape the fire, and he just needed, you know, a certain part, like a water pump or something, and he would be all set on housing. And I just thought, what a no-brainer. I mean, there are RVs everywhere, especially here in Colorado. Why don't we get an RV and drive it out and give it to somebody for Thanksgiving? And so, yeah, that's what we decided to do. So on the Sunday before Thanksgiving, I created a GoFundMe. And then simultaneously, I mailed everyone in Colorado who was selling an RV. I sent them this email. I just said, my 6-year-old daughter raising money to buy an RV and drive it to Paradise and give it to a family who lost their home. And I asked them if they would be willing to give it to us. And I didn't discriminate. You know, I sent it to people selling $5,000 RVs and people selling $150,000 RVs just to see what would happen. And one guy got back to me and said, I love what you're doing. I'll sell you mine for $2,500. And I said, look, I got a 6-year-old with me. I just need to know it's going to get us to California. And then he said, I promise you it'll get you there. So I got paid a day early and we bought this RV. And I figured, you know, the GoFundMe had raised like $50 from 2 girls from my high school that I haven't seen in 25 years. And I figured if we got in an RV and we started driving, you know, maybe my mom would donate some money or something. But yeah, we just hit the road. And that was the first time I'd ever been in an RV personally, is when we got in it and started driving. Oh, and I told my neighbors what we were doing, and they all brought a bunch of like stuff for the kitchen. And you know, when you lose your home to a fire, you know, you lose everything and you need everything. And so we tried to stock it and make it as livable as possible. So my little toothless sidekick and I packed it up and off we went. And the Denver ABC station called us right when we were leaving town. And here's the little story they did.
Woody, I don't know if you have the sound turned on for your video.
Ah, I do.
Okay, well, it sure looks great.
Thank you. I'll go to the next slide.
He's
So-
the man on the mission.
No, it's okay. So we started driving out, and then I was like, who are we going to give this RV to when we get there? Like we had no real plan. But that ABC story was pretty powerful, and I really realized how powerful the media can be in something like this. I was reluctant to do it, but a friend of mine said this story needs to be told, and convinced me to do that story or meet with that reporter. And it literally, like a station stopped us in Vegas as we were passing. We had to go through the southern route because it was snowing, and the windshield wipers on these RVs are like popsicle sticks. So it was like a 5-hour detour through Vegas to get to Paradise, but we didn't have to deal with snow. But the TV station there stopped us and did a story, and then the San Francisco station figured out what we were doing and kind of called us. And then I was trying to figure out, amidst all that chaos, kind of who we're going to give this RV to. And so I went on Facebook and found a couple of relief sites that had popped up. One was #campfire, and one was Paradise Fire Adopt a Family. And I just posted this note. I'm just a dad from Colorado. We're horrified what's happening. And, if anybody needs an RV, we'd love to help out a family. Tell us a little bit about your situation, and we'll see what we can happen. And my phone just literally melted. It was crazy. I mean, I got hundreds of people immediately responded, just begging for help. This is a little video of Luna and I driving out there. I don't know if you can hear this or not. Yeah, she was pretty good. A buddy of mine named John Bruno, who actually is married to my ex-wife's sister, called me and said, hey, if you need any help, we'll help you. You should start a nonprofit, but we can help you in the meantime with anything you need. And I had no idea what he was talking about, but I appreciated the offer of help. And I'll skip these video slides. So, so we drove out there. We met one of the people who had replied to saying they needed housing was a guy who's a father of 4. He had an 8-week-old baby, and his home burned, everything he owned burned. His job was safe, which was pretty rare because most people lost their jobs as well because all the businesses burned in Paradise. But he was commuting an hour and a half to his job and I asked him, I said, why are you commuting an hour and a half to your job? And he said, well, I want to keep my family together, and we'd have to split up if I live closer to my job just because housing is in such short supply. And I just was like, this guy's the guy. No first responders got back to us needing a place, but he did, and I just thought he was perfect. I couldn't keep my own family together, and my house never burned down. So it's like, sure, we can help this guy. Long story short, tomorrow my daughter and I, for summer vacation, are driving out our 65th RV to a grandmother who lost her home, is sleeping in her car at the Magalia Church, and she's a volunteer helping other survivors of the fire every day. And we're going to take her an RV tomorrow. But the kind of just the whole way the thing snowballed was incredible. I had an attorney call me and said, hey, if you need any legal support, let me know. And I had just gotten contacted by somebody who wanted to donate 2 RVs. And he said he wanted a charitable deduction letter, and I don't know, how to do that. And so I said, sure, take this, counselor, newly hired for free attorney, and do what we need to do. And so he filed for a nonprofit. It's RV4Campfire Family. Our GoFundMe, we raised about $40,000 in our GoFundMe. And then, I had a guy call me from San Jose who told me he and his wife were arguing about their kitchen cabinet budget because they were redoing their house, and she had a $20,000 kitchen cabinet budget, and they saw a story about what we were doing. And they decided to give us the kitchen cabinet. So he wired us $20,000 2 days before Christmas, and that, got 3 more RVs to people before Christmas, which was amazing. And We've raised in total now about $140,000. We've delivered 65 RVs. FEMA, on the other hand, I think they've spent $118 million on housing, and they've delivered 220 RVs and trailers, if you will. It's just, and the kind of folks we prioritize the people we helped by, we wanted to help veterans, first responders, any kind of medical needs, and at risk, because, you know, when the whole town burns down, you know, they're active domestic violence situations, they're single parents. You know, we got an RV to a family of 6 who was living in a minivan, and their 4-year-old had cerebral palsy with a feeding tube, you know, in the back of a van in the middle of winter. It's just ridiculous. Norovirus kind of swept through all of the relief centers, so we were pulling, you know, kind of at-risk medically people out of there to put them in RVs. But I just, you know, I still work full-time for Comcast, and everybody who worked on this is total volunteer. And I just, yeah, if this grass is what causes the fire, get rid of the grass, because, you know, this is the worst wildfire in California history. You know, and it's a pretty small disaster compared to what could happen to a lot of folks out there. I just, you know, that's kind of the end of my presentation, I think. Oh, Steve Harvey called, and we went to LA, and we're on the Steve Harvey show, which is kind of a kick. I'll send this presentation. You guys can take a look at that. I'll let you see Lena while I'm talking. But yeah, and today we're actually, I'm not supposed to tell anybody this, but CNN is here today with us all day, and we got nominated for their Everyday Heroes program. And so they're with us today, and then they're going to fly to California and meet us there when we arrive Friday and deliver the RV to the grandmother who's helping the folks at the church. You know, I think this model that we stumbled on, I realized after doing this work how meaningless my 30-year in telecom career has really been. It's just not the same feeling you get when you kind of help somebody with such a basic need as housing. But yeah, that's pretty much my story, and I'm happy to, if anybody wants to help in any way, you're welcome to. That's our Gmail email address. It's manned by volunteers, so if we don't get back to you right away, work with us. And we're on Facebook, Instagram, and Twitter, and my personal Facebook is James Faircloth. And that's about it. Oh, but to date, let me just give you our total numbers. Sorry, hang on one second. So when we're at 65 now, but of the 60 RVs, it's 211 people we've helped, including 203 children, 16 single parents, 3 first responders, 13 veterans, and 11 medical cases. Yeah, and that's it. That's my story.
Thanks, Woody. And of lesser importance, thanks for bringing us back on time to webinar schedule.
Here to serve.
Your efforts have really made a difference, and we had a couple of comments and questions. Number one was, and I'll get to the more recent ones. One was, isn't this supposed to be a webinar about invasive grasses and management? And yes, it is. If anybody has been in a fast-moving grass fire or sagebrush fire, brush fire, or crown fire knows the speed and destruction that we're dealing with. And it's stories like this and work like yours to help to bring the critical need for fuels management and the application of the latest science to these cases and these environments so that we can help communities like Paradise. To me, as somebody who works in the science delivery and exchange world, these are the kinds of stories that we need to keep in front of us, front and center, to help us remember the urgency of our work So yes, it is a webinar about cheatgrass and invasive species, and this is a big reason why. We have a question here. Whoops. No, I guess I answered it. It's gone. There's a chat. Okay, that's not new. Okay. Oh no. Oh my God. I just minimized the.
Oh, was that the whole meeting?
I still see you.
No, we're still up.
Oh.
Yeah, it's still happening. Yeah, so his webinar is in.
Oh no.
I think it's just down at the bottom.
Yeah, it's.
Well, yeah, that's this window that I have up right
No,
here.
There's another one over by the windows, like kind of above that. Is that it?
Oh, right here.
Oh yeah, because
Let's
I
maximize.
Yeah,
Yeah,
so this
that's where you
was
were.
done. No open questions, and I minimized it.
Oh, I think it might have. Oh, here's Woody.
Oh.
So we're sort of still in?
Yeah, we're in. We just PowerPoint.
Yeah, there you go.
All right.
Okay, phew, sorry, folks.
You're still there. You're with us, Woody.
You're with us,
Yes,
Woody.
I'm here.
Okay, great. Sorry, folks. So since we have just a couple minutes before we bring Dr. Tom Monaco in to talk about cheatgrass ecology and management and the basis and history, does anybody in person or online have any questions? I'm monitoring online. And does anybody here have any questions for Woody or how to get in touch with him? Somebody raised a hand. Hold on, let me find this. Okay, I'm not finding it. Can't see the slides now. We can't see the slides now. That's because we're done with the PowerPoint. We'll make sure that we can get the next presentation on. Does anybody have questions for Woody before we sign over to the other presentation?
So what do you, on one of your slides, do you have your contact information on that?
Yes.
Okay, so we can take a look at that later and get it.
Yes, absolutely.
No, I'm afraid to
Cut it
minimize.
down to a.
I'll put it in the chat too.
Yeah,
And then-
okay, that'd be
Now
great.
you can,
I'm just gonna do this.
now you can minimize
really
it out.
amazing work.
All right, here we go.
Thank you.
Sure. Okay, so Woody, if you can send us, we have Woody's contact information. We'll send that out to everybody that's participating. Just a little other note, Southern Rockies Fire Science Network nominated Woody and RV4Campfire Families to E-Town for their I think it's called E-Cares Awards. And so they've been interviewing Woody as well, and he's looking at possibly, if this gets going as a good movement, is possibly developing this model to respond to other kinds of emergencies as well. All right, Woody, good luck with CNN.
Hey,
And
thank you guys.
thanks for coming today.
I appreciate all the work you guys
On
do.
to cheatgrass and invasive species.
Thank you.
Oh,
All right, bear with me while I try to restore our previous settings here.
and this is what everybody's seeing, so I'm signed in. All right, I think I can see right here because that's our only remote speaker.
All right, I think, you want it on? Oh, okay, yeah. Here, I'm gonna see if I can get this loaded up correctly and.
Folks,
Okay,
while we're
looks good.
waiting, you can pass around your sign-in sheet. And if you would like to sign it with Southern Rockies Fire Central.
Okay, hello everybody, and welcome to my webinar today. I appreciate the invitation to come and discuss some of the research topics that I've been working on for a number of years. And the topic today is invasive annual grasses in the Great Basin. They were very specific for me to talk about this region. I gave myself the subheading of an overview and assessment of knowledge gaps.
I apologize, Tom. I messed up once again. I need to reshare that other screen. My apologies. Sorry, I know you were just getting into your groove there. All right, does that look better, Gloria?
Yes,
All right. I'll turn it back over to Tom.
thanks.
Thanks, Seth. Well, that's reassuring to know that everything's working now.
Yep, you're on.
No guarantee.
Okay, well, I gave myself the subheading of an overview and assessment of knowledge gaps, and I will openly admit that the biggest knowledge gap might be with myself. And going through the long history of research and management efforts that have been going on in the Great Basin is very daunting to try to take on. So hopefully you can bear with me today and I can share some of the things I've been able to compile. Some of the things I've been involved in my personal research will also be highlighted. First off, if you don't know who I am, I'm Tom Monaco, and I am a research ecologist with the USDA Agricultural Research Service, and the unit I'm with is the Forage and Range Research Lab. And our overall mission is to work on the development of native and introduced plant materials for restoration of the types of lands that I'll be talking about today that have been degraded in some way or another or need to be improved for some other form of ecosystem service. Work with the transition here.
Oh,
It's on.
Okay, thank you, Seth, again. First off, the region I'll be talking about is the Great Basin, and particularly sagebrush shrublands. And as you can see in this map that's been produced, it's a very extensive area. It's a very diverse area, and it is of critical importance for a number of reasons, as I'll stress later. It's very, very large. It's very diverse, and unfortunately, it's a threatened ecosystem. And the story I'll be talking about today is one of change, and it's been constantly changing. And as we are all aware of today, and what's brought us together is that it will probably continue to change into the future, and we need to be aware of these things. First off, if you're not too familiar with the Great Basin climate, I think you could probably, if you had to sum it up in a couple simple statements, it could be that precipitation is generally out of phase with the temperatures that permit plant growth, and that's illustrated here in this chart. And the other constant that has been brought up numerous times again and again, and that it does have a constant aspect, and that is that we have extreme interannual variation. What you see one year is not necessarily what you're going to see the next year. That poses a particular management challenge for us. What I'm going to do here for probably the next 5 or 6 slides is give you kind of a historical backdrop to understand kind of how we came to where we are today, why we have such a big problem, and with that as a backdrop, we should be able to see clearer into the future. First off, we're all aware that the European influences started happening here in the Great Basin in about the late 1840s, early 1850s, and those have continued up to the present date. First off, we know that there was a long era of improper grazing, basically unregulated grazing on a lot of our rangelands, and that has left a pretty significant effect over time. In addition to that, land cultivation was a very common practice, and that was practiced all over the Great Basin, from the lowlands up to the uplands, and that is a disturbance that has left a pretty big legacy on our landscapes. In addition to that, we know that we went through an era of pretty active removal of the native vegetation to try to produce things that could meet the needs of the time. And so in this case here, sagebrush was actively removed, and that was followed up by trying to convert that vegetation to a different type of a forage production system through restoration seedings. And that was commonly practiced throughout the 30s and 40s, and still goes on today in many areas. I bring these up is because all these things are all working in a compounded way throughout the Great Basin. And although we might have forgotten about some of these things that have happened in the past, they still have a very important driving role in how ecosystems are going to respond to us trying to intervene and manage. So I'm also going to give you kind of a synopsis of some of the experts who have looked at the annual grass problem much, much longer than me. And I'm going to put this in the context of pre-invasion conditions in the Great Basin, just so we can really understand some of the situations that were going on. First off, basically these sagebrush type ecosystems evolved without highly competitive annual species. And that's been looked at by a number of people. So consequently, you know, when you look at an invasive annual grass, it really is an intruder. It really is somewhat unique, and I'll be going through that later. There was widespread introduction via unpaved roads, railroads, and grain contamination. And in some cases, I think most likely some annual grasses have been intentionally planted. Livestock grazing, as I pointed out earlier, was very intense, improperly timed, and continuous in many cases up until it was regulated in the 1930s. And there's this term called promiscuous burning. You would see that in the literature quite often, as well as the historical records. It was a common practice. So our shrublands and rangeland systems were commonly burned intentionally to promote the forage production. And it's also been suggested that annual grasses basically spread into this vacuum. The plant communities had way too much bare ground due to the diminished biological crusts and perennial grass cover. And we just can't ignore these things, that this is what our ecosystem has gone through. And now there's an even earlier report put out by Richard Mack at Washington State. He spent his lifetime also looking at these types of issues, and he's put together a nice synopsis in some of his articles on this, and looking at particularly what's happened in the past. And he refers to the idea that annual grasses were basically pre-adapted for invasion. And that's a very important key word that I'll be coming back to later. And it's also quite evident that they evolved elsewhere, but in a similar type of environment. But they had, you know, thousands of years of agriculture and disturbance, where some of these invasive annuals might have evolved. So that needs to be put into the mix. And so these environments were not only, you know, predisposed, but now we have almost a perfect invader. And so, you know, Dr. Mack also points out numerous times that plant communities were heavily disturbed, and he points out that they're degraded crusts and perennial grasses. And more currently, we're well aware of the idea that a lot of our plant communities had low resistance to the spread of invasive annual grasses. And the resilience after disturbance was very low. And these are terms that we're very aware of today and that we need to be thinking about. So with that as a backdrop, I'm going to kind of shift gears here and move into a situation of trying to understand the current situation a little bit better. And I'll be talking about the degradation cycles that have continued to happen since the initial invasion of cheatgrass. And Harry did kind of touch on this a second ago. But first off, we're well aware of how our ecosystems might function when they have not necessarily been invaded or heavily disturbed, as shown in this picture here. But we know that, you know, in some cases and in many cases, we'll see our shrublands be lacking in understory. And that's that very open, bare ground situation that's basically a vacuum for cheatgrass to come into, or any other invasive annual grasses. And they produce abundant fuel that's fine. It's very flammable. It occurs at a time of year just prior to when we have the high risk of lightning strikes, and thus we start to carry fires. And we see these fires start sometimes in the lowlands, sometimes start up in the uplands. But the bottom line is no system is necessarily immune to fire now that invasive annual grasses have invaded. In fact, the Nature Conservancy now ranks the Great Basin as the third most imperiled ecosystem in the United States. So hopefully that will wake us up to the situation in how dire it really is. And so even our upland type systems can, in some cases, look wonderful, but once invaded, the potential for them to deliver some very important ecosystem services are diminished. And down in our lowlands, as Harry pointed out earlier, we oftentimes see the creation and the development of a annual grass-fueled wildfire cycle, and where the fire will keep coming back again and again because the fuel builds up, and then another lightning strike. And each time an ecosystem burns, I think it pushes us further and further away from a situation where we'd like to restore our systems back to. And how does this really happen? And that, what we're really seeing is a complete species replacement if you really look at this from the largest scale. But zooming in and trying to figure out how these types of things really happen is when you change a disturbance regime, it tends to select for certain types of species. And it just happens to be that invasive annual species are really quite adapted to that. Compare that with up in the upper left-hand corner of this diagram here, species that have a low growth rate that are long-lived. If you increase a disturbance frequency, they're going to be lost from the ecosystem, and the diversity of those species are gone. And contrast that with the bottom left-hand portion of this figure, you're going to see that it basically favors species that have high growth rates, that can reestablish quickly, and are very, very dynamic in their population regeneration. So that gives us kind of a species level perspective of how these disturbance regimes are actually selecting for annual species. And we've all seen this, in some springs we'll have just a wonderful growth of these annual grasses, but the unfortunate part of the story is that the seasonal variability quickly goes to something like this, where it's like, what's actually conducting photosynthesis out there now? Is that ecosystem absorbing the energy, and is there energy flow going through the ecosystem like it should if we were back in a diverse situation? And people have really tried to look at this with remote sensing. There's people who have really fantastic tools to kind of quantify this type of an effect. I'm going to give you just a quick example of some folks out of Berkeley who were looking at just that shift that happens. How does it really affect the energy absorption of an entire ecosystem? And here's what their type of data look like. And what you're looking at is called an NDVI kind of response. And what you're seeing is that's in the green line. And so in a uninvaded system that has a lot of different types of species diversity, you're going to see basically the ecosystem can absorb the incoming radiation. It's very responsive to changes in precipitation. After precipitation events, you might see things green up for a while. But the bottom line is there's a lot of different species, and they're able to incorporate the variability that we know the Great Basin can produce from year to year and from season to season. Contrast that with a cheatgrass invaded site, and these sites are in Nevada and in Utah. You can see that a green line basically stabilizes out, and it just doesn't have the capacity to green up and respond to the resource availability. In this case, the incoming radiation and precipitation. So we also know that there's been a lot of changes going on below ground. What we sometimes see are looking at the surface. That literally is just surface. The changes that have been going on below ground due to invasive annual grass proliferation is equally extreme. And there's been a long list of people who've been working on this for a number of years. And the most important thing to realize here is that when you go from a perennial dominated system to an annual dominated system, organic matter changes in the soil, the porosity of the soil can change, the nutrient cycling can change, and I'm just going to illustrate some of that really quickly here. Contrast that once the annual's there, and you're going to see a very mineral nitrogen rich type of a system that basically favors annuals to keep coming back. Very few species are going to be able to establish in this setting, not only just because they're under competition with cheatgrass, but because the soils have actually changed. Even when you have native wonderful species that used to be on that site, they're going to have a hard time establishing on these types of sites, and that's a huge issue. So and I'll get into this later, just removing the annual plant is not going to work. We've got to realize that the system has been altered in ways that are just tremendous. And I'll just show you this briefly. A PhD student here at Utah State University did some work back in the early 2000s showing that there's a very distinct signature in extractable, or in other words, the mineral nitrogen forms that tend to develop in annual grass dominated areas. So we know that if you go the whole summer without active uptake of nitrogen from perennial species, there's going to be a pool that builds up. That pool is shown right here. As that pool builds up, what might germinate in the fall and dive right into that pool? So the soil dynamic changes are just tremendous also. And if we look at it kind of in a slightly different way, we all know that annuals can somehow co-opt or alter the successional pathways of a site, right? One of the ways that they do it is they really kind of get involved in the nitrogen cycling. And what's shown in this figure here is that now what this is a correlation between cheatgrass abundance. So wherever cheatgrass was most abundant, that's where we see the greatest decreases in nitrogen and the greatest decreases in soil water. And so at the landscape level, if you looked at all the variety that might be seen across the landscape and where cheatgrass is abundant and where it's not abundant, it tends to have an effect on the areas that it was most abundant, and it alters it. And so I'm going to shift gears once again just to kind of recap another thing, because I think we need to kind of set the stage here for really understanding, well, how are these annual species functionally different? I think that's really important. And first off, this is like the big duh, right? It's an annual life form. But when you go from a perennial dominated system with a lot of species that are very long lived, and you go to an annual system, hopefully we can see that that's a biggie, right? It's an annual. It's also highly plastic. Now, what I mean by that is, we've all seen this. It can be really productive one year. It can, some annual grasses can be just minimal in size and growth, but it'll still produce seed. Okay, it's extremely plastic to resources, and I'll emphasize that later with some of our research. It can germinate in the fall or spring, and another thing is that there's kind of an inverse relationship between seed production and density, and that comes into play here. So let's say that you want to go out there and reduce annual grasses. You might reduce it quite a bit. You might reduce density down to, maybe 100 plants per square meter. But what happens is then there's an inverse relationship with seed production. It just tends to capitalize on the resources and produce more seed. So that's a biggie that comes up a lot in our annual grass control. Now, the other thing is that there's some commonality between how a lot of invasive annuals or just how they function. And a couple of my friends and I, we put together a book chapter just trying to assess annual grasses, and we found that there's a lot of common things being reported about invasive annual grasses, and I'm just going to highlight a couple of those here today. First off, here are some of the other annual Bromus species that we looked at. And we were curious to know, what is the literature reporting to us about some of the persistence characteristics of these species? First off, as we've already talked about, a lot of people are reporting that they alter soil resources. They alter litter production, as that feeds into the fire idea that I'm sure many people will be talking about. The other common thing is that it displaces native species, and we've seen that. And it changes the disturbance regime. Some of the conclusions that we came to is that populations persist even when environmental conditions, pathogens, and active control treatments greatly reduce seed production and seedling emergence. So the best we can throw at these annual grasses sometimes isn't good enough. So there's lots of room for us to still make discoveries and work on some of these problems. Control strategies are going to require a pretty heavy input from us, and what that means is multiple consecutive year inputs in efforts to diminish these seed banks. And as we've emphasized here a minute ago, invasion creates legacies that must be addressed. So I'm just going to kind of touch on one of the ideas. You know, this whole idea of phenotypic plasticity. I think a lot of these invasive annual grasses will display this to us. And the more we look at it, the more we're in awe of their capacity to just do amazing things, irregardless of what the resources are. And that's what really makes them challenging. I already emphasized that in some cases, you go out to cheatgrass and in some years it's only 1 inch tall. You're like, okay, wow. But then the next year it might be 2 feet tall, like this year. Who's seeing that? Yeah. Germination, once again, can be in the fall or spring. It's really versatile. It's broadly adapted, as we're seeing, you know, and it isn't just cheatgrass. I'm sure we're going to see this in a lot of the annuals that we are going to be looking at here in the future, and that we're currently looking at, is that they're broadly adapted. How are they so broadly adapted? People who are looking at their genetic base might say it really isn't that diverse genetically. Well, how's it doing it? A lot of people have said, well, it's probably has a lot to do with phenotypic plasticity. As we've emphasized here a second ago, it's very efficient in its nitrogen use. It can tap right into whatever nitrogen availability is there, and it can kind of co-opt the situation. And as I'll emphasize here in a second, the other thing that's really going on in our ecosystems is wild fluxes in temperature. These temperatures create heat stress. They can dry out soils quickly. It really creates a big problem for the native species that we try to get established. So really understanding how invasive annual grasses and some of the perennial restoration species that we're going to be using respond to these fluctuations in temperature and resources are really important. So just recently, we've been trying to come up with the simplest possible way to look at plasticity. And how do you compare grasses for that? And so we've got an article coming out doing just that. And first off, I'm just going to kind of walk you through here. If you were to plot how a plant is going to respond to changes in water, the base of their arrow would be down here, and the head of the arrow would be up here under high water. So the base would be low water, and the head would be high water. So what did it do when you give it more water? What would it do if you give it more nitrogen? What would you do if you change the temperature? It's a way for us to kind of quantify the plasticity of a species. And in this case here, we looked at Bromus tectorum, Agrippyron cristatum, western wheatgrass, blue bunch wheatgrass, Basin well-dry, thick spike wheatgrass, and big squirrel tail. And just plotting species like this, we can start to compare them. And the first thing I just really want to emphasize to you is that it's not too surprising that the most plastic species was the invasive annual grass. Okay, and it's showing plasticity and how it allocates primarily to growth, whereas some of the longer-lived perennial grasses are allocating to something different. I don't have time to get into that. They're thinking more about how am I going to allocate to shoots versus roots. Okay, but annuals are like, okay, put it in high gear. Let's just fly. Okay, and you know, looking at how annuals versus perennials respond to temperature are also a very important thing, because every process that we try to monitor or look at is probably being driven somewhat by temperature. And in this case here, we're looking at nitrogen uptake and a lot of variables that are associated with nitrogen use in grasses. And what this graphic is really kind of showing us is we actually pooled some of the data. We pooled the cheatgrass and the Medusahead response together, and we call that the annual response. Then we subtracted the perennial response. So if the annual is responding in a way very different than the perennial, it's going to be on the positive side of this line, okay? So there's a horizontal dotted line there. If we're on the positive side of that line, that means the annuals are outperforming the perennials at that given temperature for that specific trait associated with nitrogen uptake. The first thing is, like, we've known about this for a long time, since the late 60s, that these invasive annual grasses have an advantage at lower temperature. It's like, oh, darn. Okay. They can develop and grow quicker under lower temperatures than the perennials. Great. How are we going to solve that problem? Well, it wasn't until kind of recently we also realized that, well, they're also probably superior at high temperatures too. Well, higher temperatures. Okay. So I show you this just to indicate that we're dealing with some pretty highly plastic species and how they respond to variable resource availability, which is the norm, right? So we've got our work cut out for us. So I just want to kind of summarize here and give you kind of my perspective after kind of thinking about this again. First of all, I think we're at a management crossroads. As the other speaker is going to be talking about, we have numerous invasive annual grasses that are currently threatening ecosystem integrity in the Great Basin and beyond. And so we really are at a crossroads, and we need to kind of be looking for what can we learn from the past and how annuals and perennial species respond differently. How can we use it? Are there any light bulbs coming on so that we can be kind of more prepared to deal with the next wave of invasive annual grasses? Some of the questions I kind of came up with is, has cheatgrass paved the way for new invaders? Will there be an invasion meltdown? That's an older term that I started seeing in the literature, where one invasive is replacing another, and where are we going to go with that scenario? That's a scary thought. And here's a more positive one. What are the most important research questions for us to be thinking about in the future? And of course, looking retrospectively here, what has weed control experience told us so far? Hopefully that's a good jump-off point for the next few speakers. But we have an opportunity to be thinking about these things, because as we know, invasion is a process that comes in different stages. I'm hoping that we're not too far along with a lot of these other invasive species. Hopefully we can stem their movement before we get to the spread and impact phase, okay? Like I've already kind of given you a lot of doom and gloom about cheatgrass, but keep in mind, we've also been able to turn things around quite a bit on those types of cheatgrass sites. And thinking about the invasion, are we in a lag phase, as shown here by this figure put together by Richard Mack again? Are we in a lag phase, or are we in this more of a log phase where things are going to start changing really, really fast? These are just kind of things for us to be thinking about as we go into the next few talks, and that's what I wanted to leave you with. All right, so I think that we have a lot of questions that we have to be thinking about, and I just would hope to emphasize that over the next decade, I hope we don't focus too much on the simplest answers, because I mean, in some cases it's very simple. Like in the case here, this big Godzilla got taken out by a pretty wise guy. Okay, now there might be silver bullets out there, but I'm going to doubt that they're going to be obvious to us. I think instead we need to look at these as a complex, wicked problem. But here's the silver lining. I really do believe that if we use systematic application of ecological principles and adaptive management, we can really kind of move towards greater success here into the future. And with that, I might have time for another question, but if we are kind of out of time, feel free to shoot me an email at any time. I'd be happy to talk with you. Thank you.
We'll be doing catch up with questions before the break.
Thank you.
Thanks, Tom. That was a great base and place to jump off for the rest of the speakers, and a good review of what's going on currently with cheatgrass, especially regarding the nitrogen. I didn't know a lot of that. So just to clarify, we'll be going over our questions before the break. We have Tim Prather is our next speaker, and that'll take us to 2:45. We'll have a break online and in person here from 2:45 to 3 o'clock. And right before our break at 2:45, if Tim doesn't mind, we'll go over a couple of questions. And I'd like to introduce our next speaker. Timothy Prather has been involved in teaching, research, and extension at the University of Idaho. He teaches invasive plant biology and plant community restoration methods. His research includes invasive plant distribution modeling and plant dispersal. I could tell you more, but I'm going to let Tim do that. And thanks for sticking with us. And here's Tim Prather.
Thanks.
Hi, I'm Tim. Actually, no, I'm not. Sorry. I'm just going to get Tim's stuff up and running. We've had a little bit of a hiccup getting some of these presentations to advance correctly. That looks like I think you can arrow it. Yeah, I don't know that you need to use the mouse. I think you can just arrow it. But
Okay, well, we'll just check that to make sure. All right. All right, well, thanks. This is a great opportunity to introduce you to another one of our wonderful invasive annual grasses, and this is Ventenata. And have any of you been planning for a trip and you pack your suitcase and you put a lot in there and then you have to unzip that one little slide to get extra stuff in there? That's what I did with this presentation. So Ventenata is an annual grass, and it's one that's closely related to oats. It has a real interesting I'm gonna go ahead and use the laser pointer here. So if you take a look, I was trying to use the laser pointer.
Oh, we're in presentation mode.
It'll work.
So, no.
Oh, sorry. So we go back to that slide.
Okay, there we go. Okay, got it. Now, this is too high tech for me. So this particular on right here is real similar to what we see with wild oat and some of the other oats, and it allows the seed to actually plant itself in the ground. So that's one of the characteristics it has. The other is, if you take a look at this ligule right here, it's really quite long. It's a strikingly long ligule. And typically it has a node here as well that tends to be red to purple. And that can help with the early season diagnostics. When we take a look at where this particular plant is from, in looking at its native range, it actually spans all the way from Spain in the east or in the west, all the way up to Finland. And then if we take a look at how far it goes, it actually goes all the way to the Caspian Sea. So it's really got quite a wide range of where it's native to. And if we take a look at what that means in terms of latitude, it spans from northern Mexico all the way up into Canada. So that's the latitudinal range of this particular species. So if we take a look at its home territory, the species that it really grew up with would be downy brome, Medusahead, windgrass, Japanese brome. These are all species that it actually grew up with. The interesting difference is that those grasses are grasses you can find. I wouldn't necessarily say that they're totally common in their native range, but you can find them pretty easily. Ventenata is the one that has been looked at for rare and endangered status in its native range. So something very different is happening here. If we take a look at its current range, this is a map that is fairly current. I'm going to guess that it's even out of date. We put this together this last year, and I'm going to guess that it's extended its range even farther. My guess is that in Utah, it's probably got more than just one county. So, yeah, okay, hopefully just two. So that's one of the things that we are really concerned about is how fast it's moving across the West. I'm going to give you just a short summary of some of the biology work that we've been doing. One is that it is a winter annual, and it only has about 10% of its germination in the spring, and which is really quite interesting. It requires about an inch of rain, and that's with the soil staying moist over the course of that inch of rain, and the soil temperatures need to stay above 48 Fahrenheit in order for it to germinate. So sometimes in the fall, if we don't get rain, the temperatures go down, and we actually just don't get hardly any germination at all. And if we're trying to rely on post-emergent control, that just doesn't help us out very much. We've done some seed bank studies. Seeds seem to last less than 3 years. It is high in silica. It's not as high as Medusahead, but it's higher than scouring rush, which is really quite interesting. And one of the things that we've been finding is that the litter does protect Ventenata during the winter, and it seems like it may be doing some other things too, and I'm going to get to that here in a minute. This particular picture, this poor animal did not die of Ventenata, but I thought it was a pretty neat picture anyway. But this whole area here had been Medusahead, and now that is just absolutely solid Ventenata. I'm going to give you an idea of what some of the impacts are here from this particular species, and I'm going to move on into some information on nutrients. But if we take a look at what's going on with Ventenata, when we look at the total number of species, and we look at anywhere from no Ventenata cover to high Ventenata cover, we're finding that the number of species actually declines. And then if we take a look at native species, we see that with no Ventenata, we're here with this number of species, and then it does decline. So we're actually seeing plant species declining with the increase of Ventenata. And this is out of sage steppe, so this would be the same type of system that we're in here. With non-indigenous plants, right now it's not causing any difference there. One of the things that is really quite interesting is that when we look at this invasion, there's been some characteristics that have come out as very interesting. So if we look at clay content, as Ventenata cover goes up, clay content tends to go up. So there's a relationship with higher clay. We also have found that as the Ventenata cover, what we're seeing is that Ventenata cover is very high when we have low phosphorus. So it seems to be able to do really well in areas of low phosphorus, and then it declines as phosphorus increases. And there's also a relationship with potassium as well, similar. So when we start looking at these nutrient interactions, start thinking, well, perhaps with respect to Ventenata being able to replace some of these other annual grasses, perhaps maybe it's mycorrhizal and the others aren't. And so we looked at the various annual grasses that we have, and we find that no, in fact, that these are roots, and you can see the hyphae in the roots, and in all of them, Japanese brome, Ventenata, Medusahead, downy brome, they all have structures within them that suggest that they're all mycorrhizal. So there's no differences there. And I have to preface a little bit. I'm going to continue to talk about this nutrient interaction, but I have to segue a little bit and talk about this litter, because it's something that is really quite important. One of the things that we find is that if we look at from October through January, if we have litter, we find that we maintain a high seedling density, so they survive. If we remove that litter, we get a pretty dramatic decline. And so we started playing with litter to figure out, well, what's going on there? What's that interaction? And it ended up being a little weirder than what we thought. So there may be some thermal protection going on, but there could be some other things as well. So one of the things that we did is we put litter over the top of seeds and let them germinate up through that litter. And then we took these plants, washed their roots off, and we imaged the root systems, and then we measured the total amount of root material. And we found something that's really quite interesting. So this is litter from these are just different sites, F, P, and S. Don't worry about that. But what I wanted to show you was the average root diameter. So the total amount of root was the same across all of these. But what happened was when we had litter that was live, so that's this litter right here, versus autoclaved, which is this one right here, we found that the root diameter was actually smaller in all cases. So under live litter, the root diameter was narrower. So if you have the same amount of root, but the roots are narrower, perhaps that's allowing this plant to extract phosphorus. Phosphorus is a nutrient that is not very mobile, and that could be one of the ways in which this particular species is causing problems. However, that's not the whole story, and we haven't been able to reproduce this everywhere, but the other thing we did is we took that litter and we were able to look at fusarium that was extracted from Ventenata. There was some that was in downy brome. And then what we did is we inoculated seed. And this is blue bunch wheatgrass right here. What we found was, here's the control. This is the seedling emergence. But when we looked at fusarium from Ventenata, we actually saw that there were not very many seedlings that came up. So there's something in that litter, and in this case it was a fusarium that's causing some damage. You see absolutely really no response at all with Ventenata. It seems to do just fine with the fusarium that it tends to carry in its tissues. We haven't found that fusarium everywhere, but it gives us an idea that there might be some links into fungi. So that's what I wanted to talk about with respect to the biology, and I just want to mention a couple of impacts, and that's going to start with a study that we did on tree swallows. I wanted to do a study on mountain bluebirds, but swallows are really aggressive, and I couldn't get any mountain bluebirds. Mountain bluebirds is the state bird of Idaho, and I thought, why not do a study on that? But anyway, we ended up getting swallows, and so you just have to go with it. So one of the cool things about these cavity nesters is that they're central place foragers. So what they do is they actually forage a certain distance around their nest. So you can put them in high Ventenata, low Ventenata areas, and then look at what the response is. And so that's what we ended up doing in this case. So this is just to give you an idea of what high Ventenata cover is and low Ventenata cover. This is our system. So we were looking at pitfall traps. If we would have gotten mountain bluebirds, they forage on the ground, so we would have been able to pick up those differences. These are for flying insects, and you put sticky stuff on there, and then you can catch the insects. What we found was really quite interesting. If we have high Ventenata, these Hymenoptera right here, these are wasps. And this is a group of insects that these swallows really prefer. It's their main food source. And so what we see is that in high Ventenata, the numbers are greatly reduced from when there's low Ventenata. And so this really ends up stressing the birds. And it shows up here. This is, they lay their eggs in succession. They respond to the environment, so they don't do a single clutch. So they'll vary their egg laying. And so what we see here is in the low Ventenata sites, egg laying starts 7 days earlier than it does in the high Ventenata. And then they're going through here, and then there's actually a 14-day difference between when the birds actually leave the nest. So it starts a 7-day difference, and it ends up with a 14-day difference. And what we found was that the insect numbers were actually declining right in this period right here, and it caused a really significant problem, and we had fewer birds leaving the nests. So it was a cascade of effect. Plant community changes, insect changes, and then it affects the birds. And swallows are the top level predator here. And if you ever mess with a swallow nest, they're a top level predator. So that's a little bit of the impact. You'll see some of those impacts as we go through here with some of the management options, but I did want to give you that one specific one because it is kind of a unique story. The other reason why we wanted to look at that is that as Ventenata extends into the sage steppe, one of the keystone species that we're concerned about are sagebrush. What we found was that there were even more dramatic differences in the insect communities on the ground than there were in the air. And so that's a real concern when we start looking at impacts on birds like sage-grouse. So I'm going to start with just looking at releasing from competition, and there's a few studies that we've done and some different ways that we've gone about doing that. One is taking off on this litter idea. So if we remove the litter, perhaps we can have an impact. And so that's one of the things that we did. And we look at, I like to try and build decision support systems into the work I do. So we're looking at low Ventenata and high Ventenata. And then we looked at both spring and fall burns. So a student, this is Andrew Mackey right here, and he now works for Idaho Fish and Game. He wanted to burn, and I did not want to burn because the headline would not be Andrew Mackey burns down 3 houses and kills 2 people. It would have been Tim Prather did that. So, but we were able to use these panels that contain the fire, and we were actually, now that's a controlled burn, a perfect rectangle. What do you think? So what we found was that when we had low Ventenata or high Ventenata in the fall, we could carry a fire. It didn't matter. What was interesting is that if we had high Ventenata in the spring, look at all these areas. These are all areas where the grass got matted down over the winter, and that's all Ventenata, and it wasn't killed at all. So there's this dynamic is if you have a high Ventenata, you have to burn in the fall. Otherwise, it's just not going to work for you. And this is what it looks like with the control. There's the Ventenata all through here. Fall burn. This is actually a POA. That's not Ventenata. And so you can see a lot more open spaces in here. And then we also looked at combining that with spraying as well. So I'm just going to give you an idea of what we're doing with respect to management with removal of competition with Timothy hay. And what I wanted to do is, first of all, to give you a little background. Timothy is a really unusual grass. It forms these little corms, and that's where the next year's stems come from. And so if it doesn't produce those, then you don't get the stems next year. So we have to maintain about a 4-inch amount of stem in order for those corms to form for the next year. So our cut height has to be 4 inches in our Timothy hay production. So the carbohydrates are actually stored in the stem, not the root. So when we looked at control, what we found was this Axiom was the herbicide that we could use in Timothy, and it gave us very good control, and so that's what we used in our study. So first of all, we wanted to try and keep our grasses competitive, and so the first thing we did was we looked at a high cut and a low cut. So this is our high cut, which is our 4 inches, and then we had a 2-inch. And what you find is after your second year of harvest, your yield is actually higher with the high cut than it is the low cut. And my farmer friends cannot wrap their head around this. I'm cutting less and I'm getting more. But it's because they're producing more corms in the next year. So there's more stems, and so they get higher production. But the farmer that we work with in his fields, he saw this, he couldn't change his height. He just couldn't wrap his head around it. So, but we are having more and more people that are actually changing their cut height. But what it does is it makes the grass more competitive against the Ventenata. And because it's more competitive, we see those effects all the way through from our control. If we fertilize, here's our low cut and our high cut. We can't fertilize ourselves away from that difference. And when we put herbicide, the Axiom plus fertilizer, we still can't use both herbicide and fertilizer to get rid of that difference. So maintaining really competitive grasses is really important for production as well as keeping these annual grasses out. And so that was just the take-home message that I wanted to make with respect to this. If we take a look at high cover of Ventenata in this Timothy, we see that we have quite a bit of production, over 1,000. This is over 1,000 pounds of Ventenata, and that's a lot of Ventenata. You know, that plant is not all that big, just so to get 1,000 pounds, that takes some doing. But if we look at just trying to fertilize our way out of it with high cover Ventenata, we can't do it. And then, but fertilizer plus herbicide, we can really do a good job of control. What's interesting is in the low cover, so this is our control. So you can see that we have less Ventenata where we have our 10 centimeter cut. It's showing up here too. We have less Ventenata, and then these were basically equivalent. So we are getting some competitive interaction there as well. So it's really pretty cool stuff. So that's looking at release from competition. And now I just wanted to also look at, in addition to just release from competition, perhaps some utilizing seed bank. And I'm going to think about seed bank in a very broad sense to include things like rhizome production as well. So some of the species that we deal with are rhizomatous. So this is some work from Eastern Washington. A friend of mine, Ian Burke, did this study, and we did the same study at University of Idaho. But here is the Ventenata, and what's really interesting is smooth brome is a very competitive grass, and it's much taller than Ventenata, and yet if you don't take the Ventenata out, you will lose the smooth brome. It's just unbelievable. But here's what it looks like when it's been released with Esplanade. And then this is an Esplanade plus glyphosate. You can see that it just looks really very, very healthy. It comes back very quickly. So I just wanted to show you some of the data. And this is looking at, we also looked at a spring dormant treatment. And this is looking at 3 months, 16 months, and 27 months after treatment. And here we see we actually had a lower control rate. This is percent control over here, and then these are Esplanade at 5 ounces and some glyphosate, Esplanade 7, Matrix at 4. I just took a subset of them, Esplanade, Matrix blend, and then plateau. And so what we see is in terms of percent control is that we did pretty well with this 5 ounce. We did well with the 7 ounce. The Matrix started to decline through time. The Esplanade blend, 100% control all the way through 27 months. So that's pretty amazing. We have not had a herbicide that's given us this long of a control of annual grasses. So that really is very important for us. If we take a look at perennial grass recovery, so this is where we start getting into the increase both in full foliage as well as number of stems through rhizome production. We're seeing that when we look at our perennial grass, that we have some of these treatments. Here's the untreated right here, and you look at the percent cover of all these, they're all higher than that untreated. And they're really, these grasses are really coming back very nicely. And when we take a look at biomass, you can see here's the biomass of the perennial grasses, untreated, and then you can see that we're getting more for some of these. So the indaziflam, the Esplanade, we're getting increased amounts of biomass. And this, don't worry about these units, it's just within our plot. You know, it's just more for a relative standpoint. But you can see that anywhere where we had the Esplanade, whether it was with glyphosate or with rimsulfuron, which is Matrix or Laramie, that we had higher production. And glyphosate, some people try to use that, and it just doesn't give us any difference from the untreated control. This is basically the second season biomass. All right, so just have one more system to talk to you about, and this is where we're looking at doing a little bit of seeding. This is the Palouse Prairie, and it is the most endangered prairie in North America. There's less than 1% of it left. And fortunate for me, most of it's right close to the University of Idaho campus. And so we can do quite a bit of our studies just right close to home. It's a real interesting prairie. It's very high forb diversity. It's probably about the highest you can find in a prairie system. In actuality, I think the forbs actually dominate more than the grasses do. So we've done some work here, and we're looking at both spraying and then also utilizing mulch products. In some of these systems, the people don't want equipment on there. There's a tremendous amount of disturbance all around anyway, and so they're trying to minimize disturbance, and so we're looking at mulch products. So this is at one of the sites. This is what we call early spring or late winter. This is Priscilla Nehemiah. This was her project. These areas are also home to the giant Palouse earthworm. And so I had fun with Priscilla telling her how big these earthworms really were. And she's from Kenya, and she was not familiar with worms in the US. And so I maybe exaggerated a little bit on the size. But so anyway, we were looking at very good perennial grass communities, some that were somewhat disturbed, and then others that were primarily annual grass. And so we looked at seeding and herbicide treatment across those. And so what I wanted to do was to show you the results of that. If we took a look at what we were able to accomplish with respect to perennial grass density, we had a herbicide mix. It was glyphosate and imazapic. It was a herbicide called Journey. Some of you may remember, it's not sold anymore, but it was a premix. And then we used our mulch. And what this mulch is, it's basically compressed straw in pellets. And then what happens is you put your seed out, and then you throw this over the top of it. And then when the rains come, it expands and covers over the top of the seed. So it's basically hydro seeding without the hydro, okay? And so what we did is we look at how much, what's our minimum amount that we can use. It ends up being about a $250 per acre treatment if you do that. So we're not going to see that across broad expanses, but in these really critical habitats, I think it's probably a good system to use that in. So if we take a look at the control, this is our annual dominated community and our perennial dominated community. This is perennial grass density. So if you look at the perennial grass community, no surprise, we've got a whole lot of plants in those plots. And if we take a look at the annual community, no surprise, there's not very many perennial plants there. What's interesting is that when we looked at incorporating the herbicide with the mulch, you can see we had a response here. We had more seedlings and more perennial grass plants. And then where we had glyphosate and imazapic alone, but without the mulch, we didn't have as good of survival. In addition to putting out the mulch, the other thing that we did is we put out feeding trays, and we either covered those with a wire mesh or didn't, so that we could look at insect removal of seeds, or we left them open, so it could be insects, voles, birds, whatever. And we made these cryptics, so we sprayed them tan so that they wouldn't stick out, so they wouldn't be able to find them. So what we found is when we had the covers over, we lost about 40% of our seed. And when we had the covers off, we lost 80%. So when we're doing broadcast seeding, quite often we think about microsite, that those seeds have to fall in a protected area. Well, I think in addition to that, we're also losing them to seed predators. And by putting the mulch over the top, it protects them from moisture loss, but it also protects them from being found by the insects and by the in this case, it was primarily voles. And that really was the last. I guess I didn't fill my suitcase up too bad, but this is Thorn Creek Native Plant Farm, which is just by Paradise Ridge. This is one of the big remnants up here, and the family, they grow native forbs and grasses for sale. So it's a really wonderful place to work. So do you have any questions? And I think we can take questions now for both myself and Tom.
Thank you, Tim. That was really interesting. So you can hang out here. And let's see. I don't want to end slideshow. Do I? Do I want to end the slideshow?
You want to take questions right now?
I need to get at the, oh wait, here, I do it this way. That's right.
We can steal that screen back if you want.
There we go. Yeah, let's steal that screen back so I can.
Sorry.
So, yeah, Tom, if you want to come on up.
Sure.
So with regards to the blues, I mean, yeah, 1% is left. Is there an active group trying to restore or expand what's left at this point besides the university?
Yeah, it's a good question. So the question was, are there efforts to expand on the prairie? And yes, there are a lot of efforts, and I spend a lot of my time working with our soil water conservation district, both in Idaho and in Washington. And I help troubleshoot because there's always tremendous problems with weeds are their biggest issue with trying to get establishment.
You just want the question.
But people are doing this on their own. People have, they've got tremendous sweat equity, and they just are putting in, we've had hundreds of acres of loose prairie added through, and it's all private. It's really quite amazing.
And where it's expanding, is it on private lands or is
Yes.
it government?
Yeah, it's all on. What's been very interesting about working with Blues Prairie is it's almost all privately held. There's a couple of, like Kamiak Butte is a state park, and there's a couple of other areas where we have larger extent of Blues Prairie, but most of it's privately held.
Okay, we've got a variety. If we can just do, I'm sorry, we just do one online and take, maybe alternate a little bit. Let me see, one of the first questions, this must have been during Tom's presentation at 1:59, yeah. So Carl Dupolt asks, how does climate change impact this situation, which I'm assuming he means in general for cheatgrass biology and spread.
Yeah, that's a really good question. And there's a number of people looking at this, and I think that we're going to be quite surprised that cheatgrass is not done just because there's other annuals here. Yeah, there's been a number of studies to look at where it could potentially move into the future, and there's currently an ongoing effort funded through Peter Adler here at Utah State University, looking at populations kind of throughout the West, and they're going to do some climate modeling to try to figure out some of the areas that are going to be most impacted by future spread. Hopefully that will be pretty informative for us. And he's not the first to look at that. There are others who are also doing that and who have done that in the past.
We had another in-person question.
Yeah, I had a fire question. In your research, looking back over history of fires occurring naturally and how they occur now, what has changed? Compare a fire to 100 years ago versus fire now.
So just to repeat for online, in case nobody heard him, what difference does cheatgrass make in terms of the wildfire cycle 100 years ago to now?
Yeah.
Okay.
Yeah, that sounds like a question for you, Tom.
Yeah, the fires are becoming more frequent, and that's been increasing ever since the first fires. And there's some areas that probably didn't experience much fire until the mid '80s. But what's really going on is this term called megafires, and we're seeing that in the news. We're seeing that across our landscapes. When you have one side of the valley, when you have cheatgrass infestation, that basically covers the whole valley floor, and there's very little obstacle for that to jump across those barriers. I think we're going to continue to see some of these big fires, and especially when these fires move into the uplands where there's more woody fuel. Those are a big threat too. It isn't just the lowlands that are affected by this that are involved in these mega fires.
Okay, the next question looks like it's for you as well. Is there a publication citation for the mineralization of nitrogen in invasive annual grass-dominated areas?
Yeah, there's a number of people. I think some of the first people to look at this came out of Washington State University. There was, forgetting his first name, Evans, but then also Jane Belknap kind of independently was looking at that with her group on the Colorado Plateau, looking at some of the nitrogen work, the early nitrogen work. Jim Young and Bob Blank have been looking at that for a long time out of Reno. I got involved in some of this type of work in the early 2000s. So if you could Google any one of those names with cheatgrass and nitrogen mineralization, I think that you'd be able to find some of that.
I think Jeremy James had a good one too.
Yeah, certainly, yeah. Yeah, so in Oregon, the USDA group out there, when Jeremy was with them, he did a number of nice studies looking at the consequences of invasion, but also kind of illustrating that the annual grasses fundamentally use nitrogen differently. And so the idea was for a while there, could we reduce nitrogen and just solve a lot of these problems? But the problem was that the perennial grasses are also taking a hit too when we reduce nitrogen.
There's, are there any other in-person questions? Right now? No? Yes.
Sure, I guess I have another one for Tim. When you did the burns in the high and low concentration of Ventenata areas, did you take any observations or notice any observations of the propagation, the speed of propagation of the fire through those areas? Because I know you made a comment where at least the spring burn didn't burn straight through. And I guess one of the big hypotheses is that, with less annual grasses and more perennial grasses, certainly there's going to be a slower propagation of fire, allowing people to control better. So I guess I'll
Sure.
answer that question first. And then maybe
Sure.
address that
So
process.
I think with respect to the annual and perennial grass situation with respect to whether or not they're going to be good fuels to carry a fire, we were looking at these later in the season, so all the grasses are dried out. So they all do carry fire in the fall. So what we found was that our best fire was where we had lower amounts of Ventenata and more of the perennial grass, because they just carried fire much better. And it was really that attempt to do a spring burns are a lot less risky. And so if we can do spring burns, that's actually better. But it looks like that's only going to be an option for us where we have low Ventenata and just are trying to maintain it low.
Okay, we have a couple other questions here that might be better answered with typing. Cardupolt sent a link, Cheatgrass Management Handbook link from Wyoming Extension, wanting to know what people thought about that extension management. Is that something you all want to answer? No? Or type your answer?
I think you'd have to
Take a look at that.
take a look at it in order.
Okay, and another person is also interested in your textbook link for the biology of brome and other grasses.
Oh, yeah, I'll put in a little plug for that book. So actually the book is available online. It was a Springer book, and the editors of that book were Gene Chambers, Matt Germino, and Cindy Brown out of Colorado State. And it covers so many different topics. I think it's a pretty good book. It covers a lot of ground, and the chapter I was citing was one that we headed up, chapter 12 on revegetation. But that book is available online. You can go and Google it. Just search under those editors. You'll find it, and you can download a chapter.
Okay. And we've had a request, was the Ventenata swallow research published?
So that I'm doing bartering with my former graduate student, and so he's doing that. He is completing that study, and I'm doing something for him for Fish and Game. So
It sounds like a good fishing trip to me.
Well, it's not quite fishing, but no, it should be out this fall.
Okay. Another person has shared a link for rare Palouse plants and prairie restoration. Here's a question for Tim. Oh, what were the per acre rates for esplanade and matrix mix used to effectively control Ventenata?
Okay, so what we're looking at, 5 ounces with respect to the esplanade, and I think the 3 ounce rate of matrix or laramie. Matrix and laramie are the same active ingredient. So that would be the rate I think that we're thinking is going to work the best for us.
Okay. I want, yeah, go ahead.
Oh, I was just gonna say, should we take the rest of these questions and then just
I think we should, yeah,
deliver them later? So we can
sure.
take a
Yeah,
round
so
of
we-
the break.
Okay, so we're doing an online break right now. We have till about 3 o'clock, we'll resume. So we can have a bio break and run and get your afternoon coffee. And we'll see you again at 3. All right, do you guys want to write some of your answers in here?
I know that there's one in here.
Answer
that's
live.
available. I know I usually try to carry one.
Or I can.
Answer, we did this
There we go.
live.
We're in live.
That's, yes. Pardon? Joking around, the online people.
Going to be Corey Ransom with Utah State University. So Corey was the very first person to put out an esplanade trial on Medusahead. So with that, Corey, we're going to hand it over, talk about cheatgrass, Medusahead, and Ventenata solutions.
Thanks, Harry. I appreciate the opportunity to come and talk about some of the work we've been doing, really focused on management of these invasive annual grasses. It's really nice to have people like Tim Prather here, who has much more experience with Ventenata than we do, which is a fairly new species to northern Utah. But I'm going to share some of the experience of things that we've been working on. For those who are here from out of town, while you're here, it seems like the Cache Valley is a great place for infestations to start. And so you just missed our wildflower bloom, which this is actually Dyer's woad, biennial mustard that is very problematic here and has really overwhelmed any efforts that we have to manage it. But be sure and ask if you're here from out of town. There are some other species we can show you that you probably don't have yet, and we can tell you why you don't want to have those. But obviously today our discussion is focused on invasive annual grasses. And I might point out that while the most common are downy and Japanese brome, and then we have a fair amount of Medusahead, we just recently have really kind of discovered some smaller infestations of Ventenata. And so this is one that we really need to act on because we don't have much of it to our knowledge yet. But in addition to that, we're trying to manage a lot of other invasive annual grass species. Feral rye and jointed goatgrass, which we typically think of as cropland weeds, but we're seeing that more and more moving into foothill areas and even into natural landscapes. And then as we move further south, we have a whole nother set of brome species, including red brome, ripgut brome, and then another species called rat-tail fescue. I think a take-home message here, I'm going to talk about herbicides and their utility as tools to manage invasive annual grasses, but I think we can't look past all the other management that needs to take place. And so one of those things is making sure to manage these invasives early before they become widely established. You can see here that once Medusahead has taken over the entire landscape, you're really playing catch up trying to manage that grass. As well as just this idea that it really takes an integrated approach if we're going to have successful management. So again, I'm going to focus on herbicides as a tool, and really it's going to focus mainly on that, but that's not the only thing that is going to solve our problem. We have to look at integrated approaches. The fellow on the four-wheeler, that's John Squire. He was a fellow graduate student when I was here at Utah State University doing my master's degree. And it's funny how things come full circle. I remember going out with John to harvest biomass samples from his Medusahead management plots. And here I am 30 years later, still working with Medusahead management. So I hope we're learning more things as we go forward. I think as you think about annual grasses and their management, we need to think about the various aspects of the life table of something like downy brome or Medusahead. And we have to consider the fact that one of the benefits we have is that these grasses aren't perennial. So adults don't carry over from year to year. It has to go through seed production. But given that, you can think about different ways that you can kind of interrupt this life cycle process. So, and as we talk about it, we'll talk about some herbicides that really don't control plants, but they remove the viability of the seeds. So you still get seed production, but the seeds aren't viable. So that's one place you could interrupt this life cycle. The other would be pre-emergent herbicides, which control those seeds as they start to germinate from the soil. So we're stopping that life cycle early on. And then some of the herbicides we'll talk about have really great post-emergence control. So you actually have established plants that are beginning to mature, and that herbicide can come in and be applied to the foliage and control the plants at that point in time. And we have some that you'll find actually are variable in their ability both to have foliar activity and to have some persistence in the soil, which helps prevent future germination. One thing that we always overlook, and I probably will come back to it, is this idea of the soil seed bank. So even if you have a very effective herbicide that kills the plants to which it's applied, if it doesn't have soil activity, the plants are going to come back. These annual grasses have massive soil seed banks. And so even our best herbicide treatments, once that herbicide is no longer in the environment, those seed banks reestablish those infestations really, really quickly. We have a lot of herbicides that have some activity on these annual grasses: Roundup, Plateau, Outrider, Matrix, some older ones, Oust, Landmark. And a couple that you haven't thought about, Milestone, which is typically a broadleaf herbicide. I'll just touch on how it acts on something like Medusahead. And then of course one that the newer product, Esplanade, which we've been pleasantly surprised with some of the results we're getting with that. As we think about decisions in which herbicides to use, I think we have to think about what is the existing vegetation on the site, and then what is the site management of that location. And again, long-term control is going to depend on having desirable vegetation on that site, either pre-existing or some kind of a revegetation effort. So I'm going to try and talk about 4 different areas. First, I just want to say what we do know is that herbicides can target seed production and or establishment or both. And we've done trials where we apply Roundup or Plateau or Milestone, even up to the point where seed heads have emerged from that plant. And what we see that all of these herbicides, when applied at that stage, when that plant is trying to fill those seed heads, have pretty dramatic effects on the germinability of those seeds. You may not reduce seed numbers at all, but a lot of those seeds are not viable. So we're eliminating one season of seed production, if you will. But of course, if those herbicides don't have soil activity, that plant doesn't have to rely on this year's seeds because, again, the seed bank is large enough that it can reestablish. This is some work we have been doing with Milestone or aminopyrrolid on Medusahead. And you have these different application timings. We're basically making 2 applications of either 7 or 14 fluid ounces. And so you can see those were applied fall of 2017, followed by spring of 2018, or spring of 2018, followed by fall of 2018. So the idea is we're going to hit that population twice with Milestone. And so the data, the control data from 2018 is only after the applications that took place in 2017 or the spring of 2018. And what you see is you get some pretty dramatic effects of a broadleaf herbicide on the establishment and the success of Medusahead. And then if you look at the 2019 data, by time you've applied twice, you really, again, get some pretty high levels of control of Medusahead using a broadleaf herbicide. And so I just want you to think about, this isn't maybe the standard approach, but I want you to think about how would we use a herbicide like this in a management strategy. I might just mention the 14-ounce rate is a spot treatment rate and couldn't be applied broadcast, just in case you're wondering. And so here's kind of our target that we're after. So the next is application timing has a large influence on both how effective our herbicides can be and also can impact how selective those herbicides are. So if we apply it the wrong timing, we can have pretty dramatic effects on existing desirable vegetation on those sites. So last year when I was invited to speak at this, the webinar that was hosted last year, I showed this chart which shows different herbicides applied to Medusahead for control at different months. So September, October, November, spring and April, and then May and June. And keep in mind the bars are lower in the May or June because this was an evaluation in July. So those applications hadn't been on more than a month. But if you look at plateau, what we found is that the later you waited in the fall, or if you waited till early spring, you got much better control with plateau than you did with that September application timing. So my take-home message was apply really late or really early, okay? And I think part of that is that instead of relying on the soil, the dynamics going on between the herbicide, the soil, the moisture, and the seeds, you're applying the plateau directly to the seedlings that have now germinated and you're just getting more consistency. So, I asked this question, which is better to spray? Here where you can see the seedlings poking up through that heavy thatch or just spraying on top of thatch itself? Well, so we had the opportunity to do some timing trials with Esplanade and some other products. And so when we did this timing trial, we began applying much earlier than I had ever applied treatment. So our timing here was July or August or October. And what we saw was the later you go with Esplanade, which makes sense, the poor control. We didn't have the latest timing, but Esplanade has pre-emergent activity. So if you apply it after germination has occurred, those plants that have germinated, they go on to establish and be successful. So you can see earlier with Esplanade was better. But also with plateau, you see this dramatic trend where the later you wait until October, the poorer the control. But when we applied in July, we got some of the best control we've ever had with plateau. So maybe the take-home message is either apply it really early or apply it really late after you have full germination. And this is holding true in 2019 when you evaluate these plots. You can still see that relative effectiveness of the plateau treatments. But interestingly, with Esplanade, the second year after treatment, we don't see any timing of application timing effect because it has pre-emergent activity. So that barrier is still there in the soil, preventing germination. And so that control is almost complete once you go through that second year. Yes, a question? The question was how long Esplanade lasts, and I'm just going to show you what I've seen it do. So that's a great lead-in. Thank you very much. We'll go to the next. So just the idea of then the potential to injure non-target plants. This is another research site we have, which you can see is very diverse plant community, beautiful place to work. And so we applied some treatments, including Esplanade alone, Lambient, which is propoxycarbazone, Matrix, Plateau, or Roundup, and then combinations of those products with Esplanade. And so what you see is the brome control was pretty good with a lot of the products, not very good with Lambient. Then if you look at Hooker's balsam root, which was one of the main forbs on these sites, really no significant change in that species from the treatments. But look at the wheatgrass population. Obviously, we were too early in the fall, even though we were applying a very low rate of Roundup, and we significantly reduced the wheatgrass population or cover. And then interestingly, where we had a combination of Plateau plus Esplanade, we also saw a significant reduction. Those two products alone didn't really have an impact, but when we put them together, all of a sudden we see that we've reduced that perennial grass population as well. So again, this idea that our herbicide treatments definitely can have negative consequences if we're not using them in the proper combinations and at their proper timings And again, this site's a little higher elevation, and so we don't wait as late as we do on others where we know that we won't get snow cover. And so we probably were in a month earlier than we should have been when those perennial grasses were still actively growing. Okay, long-term control requires long residual herbicides. We've learned this, and there's just no way to maintain control if your herbicide's good for a year. Again, thinking about the seed bank. And prior to Esplanade, we've really not had a product that had more than about 18 months, maybe up to 2 years of residual control. And so just to kind of demonstrate this, this chart shows Medusahead cover from over 4 years. So the treatments were applied in 2015. So this is cover in 16, 17, 18, and 19. You can see the untreated, the variability that happens from year to year based on the resources available. So the cover fluctuates a large amount. It also might have to do with doing our sampling on the same calendar date, regardless of where the growing season is. And so, you know, the cover hasn't developed at that time. But you can see pretty high levels. The Roundup treatment, Accord or glyphosate, reduced that in the first year, but we see that it has no soil activity, so that population rapidly rebounds and looks very similar to the others. In 2016, we see that Esplanade alone, because this was applied in the fall, it didn't control the grasses, didn't control the Medusahead, which had already germinated. But you see the following year, then that control is pretty complete, and we've completely reduced that cover. So here's the difference. With some products, we get a nice year bump where we control it, we release desirables, but that seed bank rapidly reestablishes those plants. So here's just some results of a long-term trial, again, that was established in 2015. We had these trials both on annual bromes and on Medusahead. And I'm going to show you data from the fall treatments. And just keep in mind that Esplanade, again, is not registered for use on grazing lands, with the exception that Utah, Wyoming, and Montana have Section 18 emergency labels, emergency exemption labels that do allow application of Esplanade on grazing lands for control of either Ventenata or Medusahead, two of our kind of emergency species. So 18 months after we kind of see this, we see that we reduced that, all the treatments significantly reduced the cover of Medusahead. And you can see there's kind of a slight response of the desirable grasses. When you take out that Medusahead, that cover goes up. And you can see that's really dramatic out there where you've reduced that population or that cover to almost zero. Here we are at 30 months after treatment. We're still holding that same trend with the Esplanade treatments. And then this is just the cover. Oh, there's the picture of that in 2018. You can see the difference on the left-hand side, the Medusahead population versus the Esplanade plot on the right. And then just this spring, we barely got this data in, and we're 43 months after treatment, and we still have less than 2% cover of Medusahead in these plots. And you can see that the desirable grasses are still showing a positive response. This was early for this year, so those grasses being lower has nothing to do with the herbicide wearing off. It has to do that if we did covers today, that cover, as those grasses begin to grow, would be much higher. And then there's just a plot from the spring. So again, it's a little later in the season, but you can see the dense cover of the Medusahead. And then next door, you can see the response of those desirables when they have the moisture and the other elements that they need to be successful. Okay, so the question, what about Ventenata? We're new to the game, so Tim would have much more experience with this. But we put out a trial in 2017, and so this data is from 2018. And you can see the cover of the Ventenata, about 35%. Esplanade applied in September, so before we got germination, completely eliminated the Ventenata. But our treatments of Plateau or Accord applied in November were virtually ineffective. And so I think that's a major difference between where we're working with Medusahead. Those treatments do a really good job for us, at least for that first year. But with Ventenata, we are not seeing that. Again, Matrix though applied in November for whatever reason did a really good job. I think that's at a 3-ounce rate. And then any of the combinations applied with Esplanade, providing excellent control. And then this past year we put out another trial. So this was applied in 2018, and this is control from the spring, just visual control. So here, the larger the bar, the better. Again, milestone applied in September, no effect. So we're just not seeing a response from that. You can see as well that the plateau at 10 ounces, so a really high rate, applied either in September or November, providing only about 40% control of Ventenata. And then the treatments that look really good are those that have Esplanade. So we bumped the rate even down to 3 ounces of Esplanade per acre, and we still see basically complete control of the Ventenata. So pretty exciting things there. The Matrix, again, also doing a good job with controlling Ventenata. Keep in mind, Matrix has a 1-year grazing restriction after application. So if you do use that, you can't graze for 1 year. So here's you can see the density of the Ventenata there, early spring. Hasn't quite fully seeded out. And then here's what a plot looks like when you reduce that Ventenata. You can see some of the perennial grasses, and we got a wonderful bloom of wild onion coming up in those plots just about a week ago. So finally, I want to talk about this idea of a multi-treatment approach may be required to restore heavily degraded sites. So if we have a preference, we ought to be managing these invasive grasses while there's still a remnant community that we can preserve. It's much easier to try to bring something back than it is to restore or revegetate. And so we did some trials where we put out a whole lot of treatments. And the idea was that we would we sprayed these in the fall of 2017, and we immediately planted 1/2 of the trial. And then we left the other half of the trial so that a year after application, then we could replant and see, did it matter if the herbicide broke down, if we waited that amount of time, and how successful would these seedlings be? And we had an extremely dry year in 2017, and we got 0 establishment of any of our planted species. So now we have 2 blocks that were meant to be planted in 2 different years, but rather than let those go to waste, we decided, well, let's come in and spray one of those blocks with a follow-up treatment of Roundup. So in 2018, we sprayed Roundup to control anything that had escaped from those treatments from the previous fall. And then we planted both halves of the trial at the same time. And so now these are just some density counts, plants per meter of row for Siberian wheatgrass, just one of the species we planted in response to those treatments. So the treatments applied in 2017, plateau, 6, 8, and 10 ounces per acre, Esplanade at 3, 5, and 7 ounces per acre, and then some combinations with Accord. And then these ones on the end were just applied the fall at the time of planting. So Accord plus Milestone or Accord plus Plateau applied in 2018, planted a week after we applied those. And so what we see, unfortunately, is that the rate of herbicide made little difference in whether or not we got establishment. What did make a difference is the half of the plot where we came in and applied Roundup at the time of planting and controlled the Medusahead, we got establishment of the grass. Those treatments where we didn't, if you don't control the invasive species, you don't get establishment of the desirables anyway. So it's interesting, we expected to see a dose response, but in fact, the response was controlling the invasive species so that resources are available for the planted species to establish. And then we only applied, again, the last 2 treatments were applied at the time of planting, and we didn't see a cumulative effect. I thought maybe if you control the weed for 2 years, you'd save up some moisture, but we had a phenomenal moisture year. We actually got the highest establishment out of plots that we treated and then immediately planted after we treated them. So take-home message here is not all of these herbicides are great or should be used if your intention is to reestablish or plant additional species on those sites. So I think, you know, what we do or don't know, we have a lot of herbicides that are effective in managing these invasive annual grasses. We know that long-term control requires desirable species to kind of capture that site and hold that site. And I think we need some more information on how to put these all together. I kind of think of it like this. Here are our tools. So glyphosate, milestone, plateau, matrix, esplanade, kind of some of the most commonly used ones. They all have different properties. They all have different residuals. They all have different selectivity. So again, for any given site, I think you have to take into account, what is the property of the herbicide? What is the species I'm managing? Am I going to reseed? Is there a desirable community? And then choose the herbicides that will allow that to be accomplished. I think there's some exciting things to think about this. How do we use something that has short-term residual to establish a population, and then maybe come back with something like esplanade and protect that investment, that new seeding? Once we have established plants, can we lock out the invasive species for 3 or 43 months, right? Wouldn't that be amazing? And actually have long-term success from those seedings. So I kind of tried to come up with a decision tree. So I was like, if I'm trying to manage for these, the first question should be, is there a remnant desirable community that's present? And if yes, I probably should pick a treatment that will protect what's there already. That's going to be probably the lowest cost, probably the most successful approach. But if it's not, then I have to start planning my restoration approach. And with that restoration approach, then I have to select the herbicides that are going to work, the herbicides that have the right amount of persistence in the soil that are going to allow me to successfully establish species. And once we go through this process, it's like Tom talked about, it's kind of this iterative process. If we have desirable species established, then let's think about how do we protect those. So maybe we go with something like an esplanade to lock in that and protect them in the long term. If not, we go back to the drawing board and try again. And what we found is, because it never works so smoothly like this, the other thing that happens here is, are other weeds invading the site? And if yes, then what do we do about those? And you'll get to see that, those of you coming on the tour tomorrow. It never works out perfectly the way that you'd hope. Here's Antelope Island. Here's where we came in, applied a herbicide, and you got a great response of native grasses. Here's a site where we controlled Medusahead and we end up with field bindweed. And you know, it's hard to argue, is that a positive change or not? I'm not sure. Here's a site where a seeding was successful. So you can see that by controlling cheatgrass, you have a successful seeding. Now you have something to work with to try and reclaim that site. So again, I just think we need to think about, how do we use all of the tools we have available in the different scenarios that we're dealing with. And I think, back to my weed science background, in short, it's prevent, control, restore, protect. I think those are kind of ways we can think about invasive annual grass management. I think I've used up my time. I appreciate getting to visit with you. And if there are time for questions later, I'd be happy to answer those.
All right, our next speaker is going to be Shannon Clark, Colorado State University. She's a postdoc there. She completed her PhD under Dr. Scott Nissen. This was where the initial work with Esplanade started on cheatgrass control. So Shannon has been very intensively involved in that for the last several years, looking at efficacy, but in addition, working with other researchers, looking at all the other positive benefits that occur when the annual grasses are removed. So with that, over to Shannon.
Okay, see if I can get my pointer working. Laser pointer. Okay, I think I got it. Okay, so I really like Tim's analogy about the suitcase, because Harry called me up and said, I want you to do this talk. And can you go over pollinator benefits? Can you go over wildlife browse benefits and native species tolerance and all this stuff? And you have 30 minutes to do it. So I thought, okay, great. That's a good challenge. I think I had 90 slides in my defense presentation that lasted an hour, so I could do it. So I am going to cover all of those today, but as a weed scientist, it was hard to resist the urge to put a lot of graphs up here that show really great weed control and all the different herbicides we can use. And on this presentation, I really focused on just trying to tell a story that, you know, for me in Colorado, the last 5 years, what really has gone on and what we've seen with, you know, not just looking at controlling the weeds, but the benefits we're getting from controlling those weeds. And so I have some graphs, but not a ton, because I really wanted to just show kind of what's happened. But I think the other speakers that have gone before me have done a great job of telling us about the negative impacts of invasive annual grasses, but they really are transforming our western rangelands on a landscape scale. And so we've talked about the fire frequency today and those negative effects, so I won't spend a lot of time on those, the decreased diversity and productivity of our ecosystems. And then, of course, displaced and decreased wildlife and pollinator habitat. And this is an area I don't think we maybe spend enough time on. I think fire kind of takes our focus, and it is a big concern, and the safety problem with people and property. But I kind of am going to focus more on the wildlife pollinator habitat stuff today. And so I like to throw this, I use this slide a lot in my presentations. This is just a spread of downy brome in the US. This doesn't include the other two we've been talking about today, Ventenata and Medusahead, as well as some other annual grasses that are starting to take hold. But over 50 million acres infested in the US. And then there was a publication I saw that projected another 76 million acres are susceptible to invasion. And so when you look at this map and you think, we have to manage this, we like to say, has the battle been lost? Because that's kind of daunting looking at that. And so I won't answer that question now, but as you watch the presentation, hopefully you kind of get the answer that I'm leaning towards. So Harry went over this a little bit with his introduction to the symposium today, but Esplanade and the idea of using it as a rangeland restoration tool kind of took hold in Colorado, and that was in 2010 when the first trials were put out. But then it wasn't until 2014 when the next set of trials really went out, and that's when we hit the ground running with this research. And so I just like to show this map of, this is just the front range of Colorado and all the studies we've put out looking at Esplanade. My presentation will focus on Colorado because that's where I do my research, but these ideas really can be applied to anywhere we're facing invasive grasses that have a perennial dominated system. And so here in the Great Basin, it applies as well. But we've put out a lot of these studies and we've partnered, and I think that's been the big key, is collaboration with a lot of these agencies, these cities, these county agencies, to take our research on a larger scale basis, because the larger scale basis is where I'll be focusing today, and that's where we can really see the environmental impacts start to take shape, or benefits, I should say. So Harry showed this, so from Colorado expanded all over the Western United States. But I just wanted to also throw this up for Esplanade. It is for use in non-crop areas, and that includes things like wildlife management areas, rehabilitation sites, parks and open space. The grazing label has been submitted to the EPA, but currently Esplanade cannot be used on sites grazed by domestic livestock. And so I'm glad no one went over this because I had this in my presentation. I was worried I'm going to be fourth on the list, so someone might cover it, but they didn't. So Esplanade is a group 29 herbicide. That has some benefits in and of itself because it's a mode of action we haven't previously had in rangeland. So that also provides some resistant management strategies when we think about using herbicides. But how it works is it is a pre-emergent herbicide that inhibits root formation. And so you can see this is a picture of downy brome seedlings that were treated. And as we increase the concentration of esplanade here along this line, we start at the higher rates get complete inhibition of the roots of downy brome. So how do we use this in our rangeland systems and not impact the species that are there? Well, as someone said before, the one benefit we have is that these invasive annual grasses are annuals. And so in our systems, we're talking about perennial species, perennial dominated systems that have very few native annuals. And so the herbicide indaziflam is the active ingredient in esplanade, is very lipophilic. It binds to organic matter in the top 1 inch or less of the soil profile and stays there because of its lipophilic properties. And so that means that our perennial plants that have roots below that zone of herbicide aren't impacted as far as we know and what we've seen. And so that's how we're able to use this herbicide to selectively control invasive annuals in our systems. And so I'm going to start with just the kind of initial field development. This isn't the first study that was done with esplanade in rangeland, but the second study and the one that's been published. And so this was a field study looking at downy brome, Japanese brome, and feral rye, all problematic invasive annuals in Colorado. Looking at 5 application timings, we had esplanade at 3, 5, and 7 ounces per acre. And compared to plateau at 7 ounces per acre, which is the standard for invasive annual grasses. So this is the only real data I'll show on control of these invasive annuals, and then I'll be focusing on the benefits after this. But in this study, we see that really all 3 rates controlled the invasive annual grasses, and we combined them for this graph, all 3 species together. But really at the high rates, we're approaching 100% control esplanade at 5 and 7 ounces. By 2 years after treatment, plateau here is about 30–35% control. I want to point that out because when we go to the next slide, this is what was really outstanding to me. The perennial grass response. And Corey went over this a little bit, which was great because it kind of set the stage for what I'll be showing on the large scale. But we had over an 8-fold increase in perennial grass response at the site, which is pretty impressive in just 2 years after treatment. And so I think that we've said a long time, I think in the literature, that long-term annual grass control is really key to restoring these sites, but we haven't had the tools to really achieve that. And so this is where we're starting to see, we do have a tool that we can achieve that 2–3 years of control. And that's where we see that perennial grass start to really bounce back. So plateau here, we have a slight increase. We did get really good control with plateau the first year, but that 1 year of control wasn't long enough to give that ecosystem the chance to rebound from the invasive annual grasses it faced for years. But by providing 2 years of treatment, we see a pretty good response with that treatment. But then we move to the forb response. We see a similar story of over 4-fold increase on the esplanade at 5 ounces. Again, plateau not very different than the Czech, much different than the Czech. So we've really benefited here, the perennial grasses and our perennial forbs at this site. Then we take that further. We looked at species richness, and we went from an average of about 4 different, this is just looking at forb species, but forb species in the Czech, to about 8 different forb species in the esplanade treatments. We did get a slight increase with plateau as well. So just by controlling those annual grasses, we're allowing the ecosystem to start to rebound from this invasion. So based on this research, that's when we really started to say, okay, I mean, this has been known. Long-term management is key to reestablishment of these systems, that both the productivity with that biomass increase, but also the diversity. And the diversity is really important for a number of reasons we'll get into more later as we go through. And so based on this research, we started working with Boulder County. That's where those plots were put out, Boulder County, Colorado. And they took this research and put it on the large scale. And this is where we're really able to see those ecosystem benefits. When we, as weed scientists, when we put out a 10-foot by 30-foot plot, we can't quite, capture the whole benefit of the ecosystem in terms of, wildlife, pollinators, things like that. It's just not large enough. And so Boulder County took this on the ground. They started to apply treatments to thousands of acres using esplanade. I'll focus on esplanade as the treatment for most of this presentation, just because it's what we're using to achieve these long-term goals. So there's a site before. They're using this to prioritize sites that have a remnant population. Corey kind of touched on this, but revegetation is hard. We don't have all the information as far as, plant back intervals with esplanade. And so prioritizing sites that have a remnant population is just going to be easier as far as restoring those areas. That's before, after. You can see after the treatment of esplanade there, the response of the perennial grass, but then also you can see the shrubs and forbs in this community coming in.
Real quick, what was the time difference between the before and after that?
On this one, I'm not quite sure. I think around 18 months, a year to 18 months. Yeah. And so a lot of our sites that have remnant plant communities, we'll see this type of response within 12 to 18 months, a change like that. It's just one season of control gives those plants the moisture. They're able to grow successfully the next growing season. That's when you start to see that difference. Again, this is going to be around 18 months from when this picture was taken, but you see the ecosystem restoration. So we have a shift from an invasive annual population here over to our native perennial population here. And so that's just from the remnant plant community that was at that site. And that's, not a lot of time to get that to achieve that restoration. And I should have that was a great question. I should have put time frames on all these pictures. But again, around 18 months on when this picture is taken, it still looks like this today. And it's been about 4 years after treatment. And this is actually a feral rye infestation in Larimer County, Colorado. And so this is devil's backbone. But again, you don't see the remnant plant community under here, but there is one. And so when that was treated, this is the response of those native plants. And so the next thing I wanted to just touch on briefly, because Corey did talk a little bit about this, but our native species tolerant to esplanade applications, because we look at the control we're getting with these invasive annual grass and we say, great, we're getting 3-4 years of control, but what is it doing to the native plants that we have there? And so we actually did a study looking at that. We chose 2 sites that didn't have a high level of invasion because we wanted more diversity in our plant population there. And so we had over 30 forb and grass species at this site and some subshrubs at both of these sites. And so what we did was we looked at downy brome pre-emergent applications, and they were actually applied in June. And the reason we chose June was because everything was actively growing, but we also looked at some broadleaf herbicides to evaluate their impacts as well. I won't cover those today, but that's just why the timing was chosen as it was. But this is just views from the site. So you can see we have a pretty diverse population of native forbs here, native perennial forbs and native perennial grasses. And so I'm not going to show all the graphs that we did for this, but just a visual of the downy brome response. So again, we see, esplanade holding for 2 years. You can see that looks pretty healthy there. Plateaus, the cheatgrass is starting to come back in. But what I really wanted to talk about was the community composition impacts. And so what we did was we counted individual plants throughout the plots over the course of 2 years, and then ran that through what we call a permanova analysis to determine, are we having an impact to the community composition? And we looked at it in terms of richness, and then we looked at it in terms of abundance. Abundance being the counts that we did for the plants. And so we found with all of our esplanade treatments, if it was just esplanade alone, we had no impacts to the community composition. In a few cases, we had increases in abundance. and richness, but for the most part, no impact. So we're not having a negative effect on the community. In terms of the broadleaf herbicides we did, but that would be expected because forbs would be impacted by broadleaf herbicides. And so if you want more information on this and all the different data collection we did, it was just published in Invasive Plant Science a couple months ago. So the next benefit I wanted to get into was the litter or thatch layer component. And so the reason we care about litter is because we've heard a lot about it today. It carries fires, it's a fine fuel, but it also protects those invasive grass seedlings to allow them to grow better. It kind of creates a microclimate and works to their advantage. And so removing that thatch layer has multiple advantages. And so we've seen across our studies, this holds true, that it's mostly decomposed after 12 months. So if we have a treatment that holds in about 12 months, that litter layer is broken down. Now, I don't think we have enough information, or someone else could speak to the Medusahead or Ventenata decomposition. There's thoughts that maybe it could be longer because of the silica content, but as far as what we've seen with feral rye, downy brome, about 12 months. If your treatment holds, we've broken down, we've opened up the interspacing between our perennial plants, which is what is a part of our natural ecosystems in the West here. And so by removing that litter layer, or that fine fuel, we're utilizing these treatments for fire breaks. And so here's just an example of how it can be used. Treating on this side of the road, acting if you had a fire coming through here, the road plus this treatment acting as a fire break. Again, this treatment was specifically put out by Larimer County, Colorado, to act as a fire break here for a neighborhood that's there. And again, just showing that fine fuel reduction when you have treated areas. And so we talk about fire a lot, but now I want to focus on the benefits for pollinators. And so what we noticed was we have treatments like this before, and we treat and we have a really good response of the forb community in these areas that do have a remnant plant community. And so that led us to seek out someone that was a pollinator expert, because I by no means am. And so we did we worked with a researcher at CSU, Arthi Seshadri, and she knows pollinators, and so she's a pollinator expert. And we looked at the benefits of treating these areas and what that means in terms of pollinators. And so just to kind of emphasize why invasive annual grasses are impacting pollinators so much, it's probably obvious, but I just wanted to make the statements. Annual grasses are not just a problem for native plant species, but also native pollinators. And that's because they reduce the abundance of flowering forbs, but also the richness or the diversity. And so if you think about pollinators in terms of their diet, just like us, if we just ate ice cream all the time, that would not be healthy. Pollinators need a diverse selection of floral resources. And so these annual grasses are depleting that. They're reducing the richness at these sites. And so then they also just rely on floral resources for food and shelter as well. So the study that we conducted was in partnership with Boulder County as well. And so there were, these had to be conducted on large scale treated areas because you're not going to see the pollinator benefits, again, in a 10 by 30 foot plot. And so we had some large scale treated areas that were treated with esplanade as the treatment. So they did have very good downy brome control, and they were paired with a site that was not treated. So there was 3 of these type of paired sites in Boulder County. And so what they looked at was pollinator visitation, the number of floral resources, and that's like how many flowers are flowering on a plant. So the amount of floral resources that might be available in an area. And then also the species richness, because like we talked about, these pollinators need a wide variety of species. And so each site consisted of the treated and non-treated area, and they made weekly observations June through August. And so this is just some of the observations they did, timed pollinator observations, where they would sit at a transect site for a couple minutes and observe how many pollinators visited that meter square area. They also did sampling with meter squares here, where they looked at those, like the number of floral resources. So how many plants were flowering, and then how many flowers were on those plants in that area. And then the random walk census would just to get to evaluate all the forbs that were in bloom in that site, and how many different ones there were to get levels of richness. And so that's just an example of a the non-treated site, one of them at Rabbit Mountain Open Space, and then one of the treated sites, Culp Open Space. And so when we just look in terms of richness, we can see in the treated areas, we have a lot higher richness scores here. But what I really like is this graph here, where we look at the species richness in terms of how many species in the treated area and how many species in the control by week. And so these were their weeks of observation down here. And you can see, like in week 1, they only had richness in the treated plot. They only had flowering forbs in the treated plot. And so these are all based on what's flowering at the time. And so week 2, you see you have like 3 in the control. You have 1 that overlaps. That's what that diamond is. And 11 up here in the treated. And so you can see, especially in the early to mid season, there's a huge difference in the amount in how many different plants are flowering at the time of their observations. And why this is important is because if all your flowers or forbs flowered at once, pollinators would only be able to use those resources during that time. And so what we're seeing is an extended amount of resources through the growing season for these pollinators. And then they just ran Shannon's Diversity Index, which is a really common measure of biodiversity, and found that in treated areas, they looked here, the blue is early season, red is mid-season, and green is late season, that there was a lot more diversity overall in all the seasons, but especially in the early seasons for these sites. Okay, so moving on to wildlife resources and habitat. So we looked at these benefits in as far as our diversity and richness in our plants, and then for pollinators as well. But what about our browsers? And so especially in Colorado, this would be our mule deer. And Boulder County is a big mule deer winter range. And so they feed off of shrubs, and they feed off of, in shrubs each year grow, and they put on leader growth. And that's what the deer really seek after to browse. And so if there's not a lot of new leader growth, that can impact the deer's diet and what they're in their nutrition. Deer don't, so elk can browse on shrubs, they can change over and graze grass, but deer don't do that. They really rely on browse these shrub species to support themselves. And so we were out with Colorado Parks and Wildlife, and they noticed, and one of the wildlife biologists noticed, there was a lot more leader growth on the shrubs in areas that have been treated for downy brome. And so that got us thinking to evaluate that further to see the impacts we're actually having on shrubs in areas that we've controlled the cheatgrass, especially long-term control. And so he also informed us that, so Colorado Parks and Wildlife keeps numbers on their deer herds, their elk herds, all the herds in Colorado, and deer herd populations have been down. And a lot of that is due to areas being impacted by these invasive winter annual grasses in our area, especially downy brome, and reducing just the amount of available browse that they have. And so this is just an example of a downy brome invasion at a site you know, that it is mule deer winter range, and these are some of the shrubs there. And so these were the desirable shrub species that Boulder County specifically identified. Sumac's going to be one of the big ones and mountain mahogany for deer, but they do browse on all of these. And so what they did was we contacted another person with Colorado Parks and Wildlife, Danielle Johnston, and she's kind of developed a method for analyzing shrub response and shrub growth. And so we used her methods, so Boulder County, Derek Sebastian with Bayer Crop Science went out there. They laid transects at 6 different sites in areas, in one area that was treated, one area that was non-treated at each site, and evaluated along a 200-foot transect the leader growth. And so these are just some of the differences. I won't show all the data today, but 14-inch leader growth here in an area that was treated on antelope bitterbrush. That was the longest leader. 2 inches was the longest leader in the non-treated area. So I don't think a lot of times we walk through and realize how impacted the shrubs are. They're definitely being impacted by this invasion of these invasive annual grasses. Again, looking at rabbit brush, 30 inches longest leader growth, 13 inches in the non-treated for the longest leader growth. And that's just some of the damage noticed by that deer are doing, just trying to find browse in these areas that are impacted by downy brome. Also looked at thatch degradation. Again, 842 pounds of fine fuel in non-treated areas when this was averaged over the sites, 7 pounds in the treated area. So fuel reduction, that also protects the shrubs, because if a fire goes through, that annual grass underneath really assists in burning the shrubs in to the point where they a lot of times don't come back or recover. Perennial grass biomass, again, same response we've seen in other studies. 22 months after treatment, the non-treated 45 pounds of perennial grass per acre, 1,000 pounds of perennial grass per acre in the treated area. And just the last measurement they took was weed species cover, just evaluating it along their transects. And you can see in the non-treated area, dominated by downy brome, but you also have yellow alyssum, which is an exotic annual that also utilizes moisture, takes away moisture from perennials. And then we even had some perennial and biennial species in there as well. In the treated areas, we actually really had no cover of weed species. And just a visual, I like this picture because you can actually see the difference in growth on this rabbit brush on the treated side versus the non-treated side. And then Hall Ranch, again, this is the treated side and a lot more growth over there. And so I think I'm right on time, hopefully. This is the end. So just kind of what I would call the paradigm for long-term restoration success. And I think we've gone over all of these points today with the other speakers, but long-term invasive winter annual grass control is really critical. If we don't have long-term control, we're not going to see that response from the native ecosystem. And these are in areas that have a remnant population. We've had some talk about the soil seed bank, and targeting that soil seed bank is critical because, as other speakers have pointed out, that's what annual species rely on. And so in a perennial dominated system, if we target that annual seed bank, that's where we're going to start to have success. And then just reestablishing those perennial grasses and forbs, and whether that's through a remnant population or revegetation measures, that's how we're going to increase the resistance and resilience of the ecosystem to ward off future invasion. And so through all of this, that's where we can get our benefits to the ecosystems, as we just went over. So our pollinator habitat increases, wildlife habitat increases, reducing the threat of wildfire, and then just simply increasing the diversity and productivity of our ecosystems. And so with that, just some quick acknowledgements, and there's my contact information if you have any more questions.